Good morning, friends. Today we will discuss on numerical on composite wall. We all know that the composite wall is the combination of two wall which may have same conductivity or different conductivity, same cross section or different cross section. Uh, Now the question is, we have a brick work of a furnace. Suppose we have one furnace. For that we have to build a wall with layers laid on fire clay. The thermal conductivity of fire clay is 0.93 watt per meter into Kelvin, and it is also covered with the red brick having thermal conductivity 0.7, and the space between the two is filled with the crushed diatomite brick having thermal conductivity 0.13. And the question is, what should be the thickness of red brick layer if the brickwork is to be laid without diatomite? So here in first case we used diatomite, and in second case we have to find the thickness of red brick if we do not want to use diatomite between two layers, so that the heat flow rate through the brickwork remain constant. Here in both case heat flow rate means Q is constant with the same temperature of furnace and outside temperature. So T1 and T2 temperature, inside and outside temperature, is same. So for the first case we have three layer. One is for fire clay, second layer is for diatomite, third layer is for red brick, and in second case we are not using diatomite, so first layer is for fire clay and second layer is for red brick. So for the fire clay we are using K1, the thermal conductivity for that is K1. For diatomite we will use thermal conductivity K2, and for red brick we will use K3. Also the thickness of all layers is given. So for fire clay the thickness is 0.12 meter. For diatomite the thickness is 0.05 meter, and for red brick it is 0.25 meter when we use diatomite. And in case 2 the thickness of fire clay is 0.12, and we have to find the thickness of red brick. So this is our main intention. Here the temperature is in both case T1 and T2, same for the case 2. So for the single wall we know the equation of heat flow Q is equal to T1 minus T2 upon resistance. So for single wall the resistance in conduction is x1 upon x upon Ka. X is the thickness, K is thermal conductivity, A is cross section area. Here the cross section of any layer is not given. uh, for the first case, when we use diatomite, so we will find the resistance in this case. As all three layers are in series connection, our equation of resistance become R1 plus R2 plus R3. So total resistance sigma R is R1 plus R2 plus R3. We know the equation, it is X upon K. So for the fire clay it is X1 upon K1A, plus for diatomite it is X2 upon K2A, and for red brick it is X3 upon K3A. Now the cross section of all layer is same, so we are just putting A for the cross section. By solving this equation, we are putting all values in this equation, and by solving this equation we get the value of sigma R in terms of A. And for the case 2, when we are not using diatomite and we have to find the thickness of red brick, so as it is in series connection, the equation become R1 plus R4. We are using 4 for the red brick, and it is unknown. The thickness of in this case is unknown, so our equation R1 plus R4. We know the resistance equation, it is X upon K, so X1 upon K1A plus X4 upon K3A. We are putting all values in this equation, and we will get this equation of resistance without diatomite. Now, as the given in the numerical, that the heat flow in both cases is same, so the Q is equal to T1 minus T2 upon sigma R is same as T1 minus T2 upon sigma R0. R0 is used for the heat flow without diatomite. So from this equation we can conclude that the sigma R is equal to sigma R0, and putting this value of case 1 and case 2, here the X4 is unknown, as we put this in equation. So by solving this equation we can find that the thickness of red brick is 0.15193 meter. Mind well, in heat and transfer subject, in the numerical, thermal conductivity or any other terms mostly given in meter unit. So we will use the thickness of any material in meter. In general mechanical numerical we are using thickness in mm, but for heat transfer many terms are available in meter, so we will use the thickness or length in meter. Thank you.